Hello, I am Michael LaCourse. This is the third presentation for the Environmental Management class in August 2018. Management of Big Game Migration in Island Park, Idaho. The topic is Effect of Wildlife Corridors on Big Game Animals in Island Park, Idaho. The vision statement is eliminate adverse vehicle-wildlife interaction in Island Park, Idaho to protect animals and motorists while maintaining migratory patterns. The following management alternatives are viable options in the Island Park corridor. First, reduce the speed limit. This would increase the response times for motorists when they encounter big game in the roadway. Second, build wildlife over and underpasses depending on terrain allowances. Third, construct a system of wildlife crossings with large animal detection systems. Both options will necessitate the construction of wildlife fencing. Fourth, reduce nighttime speed limits in selected sections. These sections will be those which have the highest incidence of vehicle-wildlife collisions. Fifth, cut back vegetation to increase visibility for motorists. This would allow motorists to see animals more clearly before they enter the roadway. For the plan, a combination of two management alternatives was selected. This was due to the terrain allowing for both and cost considerations. The selected alternatives are to construct wildlife overpasses and underpasses depending on terrain allowances and constructing a system of wildlife crossings with large animal detection systems. These options will allow animals greater movement while also protecting motorists. The terrain allows for wildlife crossings to be constructed in the straight sections of the roadway and building over and underpasses in sections with limited visibility. The cost of constructing a wildlife overpass is currently estimated at $22 million. The fencing associated is estimated at $70 per linear foot. Designating certain sections for wildlife crossings will allow cost saving for the fencing as well as cost saving with the large animal detection system. Current systems can detect animals through radar within 1.54 kilometers and can also capture speed data of vehicles traveling through the area. The cost per unit is estimated at $287,000. Not building 1.54 kilometers of fencing represents a cost saving of $707,000. When the system activates through animal movement, a warning signal is activated, alerting drivers of animals in the roadway. The success in this plan is measured with the following criteria. A reduction of at least 40% in vehicle-wildlife collisions within 2 years of initial plan implementation, with successive reduction on full implementation of the plan. Currently, 120 large animal collisions occur annually in the area. Due to cost and labor involved, the plan will have to be implemented in stages. Second, ensure that the structure promotes the movement of animals through the corridors. This can be assessed through track beds, which are sand beds along the road, to estimate number of animals crossing through the corridors. This needs to be established before implementation of the plan to gather a baseline crossing number. Third, the response of motorists to the warning system. A reduction in speed in response to the warning signal is expected. This can be easily measured through the capabilities of the radar detection system. Fourth, the plan must maintain the wildlife population and ecosystem processes in the area. This means that wildlife and ecosystem diversity is not adversely affected through the corridor system. Fifth, winter mortality stays within expected levels for conditions. This would indicate that the corridor system does not affect the access of animals to food, water, and shelter. The combination of these criteria will indicate success if expectations are met or signal a need for reassessment. These are the references used to develop this presentation. Thank you for listening and have a great day.